The second question again, it's interesting. It is again another frame. So can anyone say which class of this frame belongs to? So you would identify the class of frame looking at if I remove the support. So the support here for the frame is at point A hinge, at point E hinge. If I remove both of this configuration would collapse. So it is non-rigid. And if I draw free body diagram of an entire frame with the consideration of 1000 Newton given for case 1 at point B vertically down, at case 2, that is the second part of problem, at point D, then you see there are 4 unknowns, so it is non-rigid, statically indeterminate. Statically indeterminate frame. So how can you solve this class of frame? It is mandatory that you have to dismember and solve. And this is one of the very good problem. It's not only for examination point of view you should know. Also you see that that brings in a lot of basic concepts, ideas of two force members, right? So here you are asked to solve this problem for support reaction at point A and point E. If 1000 Newton force is directed vertically downward at point B, a case 1, and at point D for a case 2. You have understood something called the principle of transmissibility of force, one of the fundamental principles. That would be applicable for a rigid body, not at the connected bodies. So the frame is a connected body system. So my question is, having this 1000 Newton force at B and solving for the reaction, or having this 1000 Newton force at D and solving for reaction would be different, or are they same? That's a question. Can anyone answer? Pranesh? Aravind? Kishan? Pranesh Pandey left. So you do not speak, right? Anyhow, let me go ahead with the teaching, and you would listen whenever you feel that it's important for you. Right. So what is that you have to understand here is, by having this force 1000 Newton applied at point B for a case 1, 1000 Newton acting, is not same as applying the same force at point D. If you apply this force at point D, the reactions at A and E would be different. If I apply at point B, it would be different. If this entire frame is of a rigid body, not as a connected body, and then I can have this force applied at point B or anywhere along the line can be applied, would have the same effect, I would say. But in a connected system of bodies like frames or trusses, you have to look at the point of application of load. You cannot the transmissibility of force, principle of transmissibility of force is not valid on connected system. That you have to understand. That is why this problem given now to you. So in case 1, you can take as the 1000 Newton force is acting at point B. Then what would happen? The member A, B, C become multi-force member, and the member E, D, C is become two-force member, because this load is acting at point B. So the reaction at in this E, D there is no load, and C would become two-force member. So that is an idea. So to solve this, first let us draw free body diagram of an entire frame. So I will consider here this is a hinge. So I will have reaction AX and reaction AY, the component of reactions. Similarly, I would have at point E reaction EX and reaction EY, right? So now this is an entire frame free body diagram. There are 4 unknowns. and I cannot solve for all four unknown without dismembering, without considering an individual component. That's why it is called statically indeterminate. But if I consider an individual member free body diagram, I will be able to solve. That's what you understand from this class of frame. So now let us find out partially whatever is possible from the entire free body diagram. So what does that? If I take moment at point A, I would be able to find out what is this Ex, because Ax, Ay passes through this point, will not participate in the equation, and Ey line of action is in this through point A, so that also won't come. I would know what is my Ey. So let me first apply moment about point A, sum equals 0. So if I do that, I would get now Ex into this height, which is 400 mm, and that creates about point A, what moment? Counterclockwise sense moment, so this is positive. And then look at 1000 Newton force at point B, and this distance 240 is a moment arm, create clockwise moment, so minus 1000 into 240, that's equal to 0. So now Ex I would get from this 1000 into 240 divided by 400. So I would get Ex value from this. The value of that is coming to be 600 Newton. So this is 600 Newton. And the direction, since it is positive value, the direction assumed is correct. So Ex to the right. So this value here is 600 Newton to the right. Right? And similarly, now I can also find out what is my Ax by applying second equation, sigma Fx equal to 0, considering forces to the right positive. I have now Ax plus Ex equals 0 because there is no external horizontal force. So that solves for Ax equals minus Ex. For Ax is minus 600 Newton or 600 Newton, and the direction here I assume to the right should be changed. So this is the direction at this point. That's my Ax. In this diagram, I did not change that. Instead, I put minus 600 here. Right? It is also, see, when I have sigma Fx, both are cancelled. So I get my configuration back like that. And then my third equation is now Ay plus Ey equals 1000. Right? If I apply my third condition of equilibrium, that is sigma Fy equals 0, I would get Ay plus Ey minus 1000 equals 0. So that's equal to 1000. So that's my equation 3. Right? So this is my equation 1, 2. This is my equation 1. This is my equation 3. So in this, I have two unknowns. I cannot solve unless I know one of that. So now what I will do, I'll have to find Ey, and then I can get what is Ay. So for that, I would have to take one of this member out of these two and its free body diagram. So what is that member I would consider? I would consider wisely a two-force member instead of multi-force member, because this member EDC, free body diagram, I have now in this Ex known, which is 600 Newton, that's Ex, and Ey is an unknown. And now 1000 Newton force won't be accounted in this because that is acting in this case at point B. So there is no force at B, and the reactions at point C should be just opposite to whatever that I have here. So that should have here, this is Cx, and my Cy is like this. And now from this it is very clear that since the equilibrium of two-force member, what is necessary is the reaction at this point E and reaction at point C should be same magnitude, opposite in sense, directed along the member. So if that is so, I would have here simply Cx sigma fx equals 0 till Cx equals 600 Newton. By knowing Cx value, I can find out what is my Cy value just taking moment about point Ey, right? So take moment about point E, and that's equal to 0. So if I take moment about this point, I will get what is Cy. So Cx is 600 Newton, and that would create a point E, counterclockwise moment. So 600 into moment arm distance is this distance, which is 240. This distance 240. So 240, and that is positive here because that creates counterclockwise moment. Whereas Cy into this distance creates clockwise moment. So minus Cy into moment arm distance. Look at the configuration geometry. You have 240 plus 240, so 480 mm. So 480 mm, right? And these two will not participate in the moment equation. So this is equal to 0. So I would get Cy equals 600 into 240 by 480. So what is that I'll get? This is going to be 2. So it's going to be 300 Newton. So I get positive value of that. So the direction assumed here, Cy, is correct. It's acting downwards. So if I know that, I can find out now Ey. That should be same as this magnitude, and it is opposite. So that is also evident from applying this equation. Sigma Fy equals 0. It's positive. I would have Ey minus Cy equals 0. So Ey minus 300 equals 0. That's going to be Ey equal 300 Newton. And it's positive, so the direction assumed here is correct. So that is upward. So that is how I just solve for Ex, Ey and Ax, Ay in this case, right? So the answer here is this Ey is 300 Newton, and Ay now can be obtained how? Ay can be obtained now by from this equation 3. Now from equation 3. So when I say equation 3, I have to go back to this entire frame free body diagram. So I have to have both entire frame free body diagram as well as an individual component free body diagram to solve this problem. So from equation 3, Ay would be 1000 minus Ey. So Ey is 300. So it is 700 Newton. And since it is positive, the direction is correct in that consideration. So what was that is considered upward. So Ay is 700 Newton upward. So you have solved now all the reactions. So what is now your answer? So you have Ax equals 600 Newton, and that is to the left. Ay you have now found out 700 Newton upward, and Ex, which is you got 600 Newton to the right, and Ey you just have got 300 Newton upward. So this is your answer for case 1. Case 1, if 1000 Newton at point B acting. The second case is if you have done this, you get 5 marks. And also you are asked with the second case. So what is the second case? It is if 1000 Newton is applied at point D. So if it is applied at point D in this same frame, let us look at the same frame. The same frame. Let me copy this. Take it 1 second. this frame. Now you have this load, external load 1000 Newton applied at this point. So there is a difference. So applying here 1000 Newton would change the reactions over here. If I solve this again, considering this is my AX, AY, EX, EY, I would have now, see now what has happened. Since this 1000 Newton force is now on this member EDE, EDC is not two force member, that become now multi-force member, whereas ABC become two force member. At this I have a reaction. I would have a reaction just opposite to this. So and the same way, if I continue now, considering entire free body diagram, that would solve for my reactions at A and E. So by considering this is case 2, right? Case 2. Now at point D, this force is considered. So by taking moment at A equating to 0, I would solve for what is at EY. This can be solved. That would be same as whatever that we had earlier, because the moment arm on this force is not changing. So I would get now EX into 400 minus 1000 into 240 equals 0. So EX, I would get 1000 into 240 by 400. It gets same 600 Newton again. So this is not changing. EX is not changing. So similarly, now sigma F x equals 0. If I put in this, I get AX equals minus 600 Newton. So that is 600 Newton to the left. That is also not changing. So what would be the change in value of AY and EY? There will be a change. So that you can see. And for that, my third equation here is AY plus EY equal 1000. This is my third equation that comes from having vertical equilibrium equation applied. So if I apply this, I get this equation. So in this, I have to get my EY and AY. So I cannot have both of them from this free body diagram. That is where I should dismember and solve. So when I dismember again, I would always prefer two force member because that is easier. Three force member also you can consider and find out, but that will involve again writing equation. But two force member by observation itself it gives. So let me now have consideration of my two force member, which is ABC. So this A, this point is B, and this point is C. And at point B there is no force. So whatever that I have now here, I had AX is 600. So let me just put that here. I'm taking it now with the correct sense. So here it is minus 600. But I put it here as I know now it is to the left, so 600 Newton, and AY is unknown. And if I have it like this, my CX should be in this direction, CY should be in this direction, then only this will be under equilibrium. So this is my CX and this is my CY. So by observation itself now, I would say that CX equals 600 Newton. This comes from where? From this equation, sigma fx equal to 0. So if I apply that to minus 600 plus Cx equals 0, so Cx is this. So I have now determined Cx, which is equal to 600 Newton. Now Cy I can get by taking moment at point A. So taking moment at point A equating to 0, I would have Cy into this distance, which is 480, minus this is 600. So 600 into this height, which is 160, which is 160 here, this height. So look at this dimension. So 160, that's equal to 0. Therefore, Cy going to be 600 into 160 by 480. This is 160 by 480. So this is 3 times. So I get the answer 200 here. 200 Newton, right? Newton. That's my Cy. And it's positive, so the direction considered is correct, acting downward. So now this Cy is 200. And therefore, Ay I can get from this diagram itself by applying vertical equilibrium equation. That would be applying sigma Fy equals 0. I have here Ay minus Cy equals 0. So Ay equals Cy equals 200 Newton. And Ay acting upward. So this Ay is going to be 200 Newton now. Right? So I have now Ax 600 Newton to this Ay, and I have to get now Ey, Ex, right? Ex is found out, Ey I have to find. So I have to get this equation back again. This is equation number 3. So equation number 3 is Ay plus Ey is equal to 1000. So from equation 3, Ay plus Ey equals 1000. So Ay is just 200 we have found. So Ey equal 1000 minus 200, I get 800 Newton. 800 Newton. And the direction is as incorrect as this value is positive, Ey. So now in the second case, what is my answer is, I have my Ax 600 Newton to the left, Ay's value is 200 Newton upward, and Ex happens to be 600 Newton to the right, and Ey, see now this is 800 Newton. So this, in this, you have this Ax, Ex may be same in both the case, but Ay value and Ey value is different in case 2 compared to that of case 1 answer. Case 1, Ay is 700, Ey is 300, whereas here it is 200 and 800. That's all because of point of application of that force. So this is what you should understand. If you have answered both the 5 marks each, you'll get, right? If you have drawn correct free body diagram in both the case, you get 40% mark, 4 marks, and your answers are correct, then you get the remaining marks accordingly.